Hello, and welcome to Leaders of Code. If you are joining us for the first time, this is a segment on the Stack Overflow podcast where we get senior engineering leaders together and we talk with them about the work they're doing, how they build their teams, and the biggest challenges they have in front of them right now. My name is Ira May. I'm the B2B editor at Stack Overflow, and I'm here again with my colleague, Ben Matthews, who is engineering director at Stack Overflow. Ben, thanks for coming back on the show with us.
Thanks for having me. Excited to be here.
Absolutely. Our guest today is Eric Anderson. So Eric is Director of Engineering at Intuit. Eric, thanks so much for joining us. How's it going?
It's going great. I'm super excited to talk to you all. Thank you.
Amazing. I'll jump right in. I know we have a lot that we've been wanting to talk about, and I wanted to start by just thinking about something we've had very much at the forefront of our minds at Stack, which is the importance of human critical thinking in relation to coding speed. When AI tools are making code generation essentially instantaneous, we need to think about human critical thinking, I think, and context and oversight in a different way. So I wanted to start by asking you, Eric, in your work with your teams, how are you thinking about balancing the speed benefits of AI tools against that need for human critical thinking?
I would say that it's this incredibly interesting time in the industry right now because never before, I've been doing this a number of decades, and I would say never before has the incremental cost of a line of code been cheaper. It essentially is about the most inexpensive thing of anything that we do in terms of software development is actually produce code. And what that's really created is this very interesting dynamic where it used to be that, coding was the thing you were always worried about, from a scheduling perspective, from a risk management perspective, from a rollout perspective, from a rollback perspective. And now, we've started to really look at how do we reshape how we work? What does it mean to actually, build a feature? What is a system design? What are the skills that engineers need in the organization to be successful? Because if you're a, rock star programmer, that's not necessarily the thing that is going to make you a rock star software engineer in this new day and age. And so I think it's a really exciting time to be a software engineer. I think that in many ways, a lot of folks a while ago were saying like, will software engineering go away? It's like, I think we're making more software every day now than we ever have. I just see the need for software development, software architecture, software resiliency support, engineering, all of these things becoming more and more and more. And I think to the core of your question, at the heart of all of that is a human that actually has to make high judgment decisions about the best way to put this code together and make sure it generates value for customers.
I'd love that, especially the insight into a cost. The cost per line of code now has never been cheaper. I think that's the resounding thing of how mindsets are going to have to maybe change of how we look at things. I think the big question that's challenging us everywhere is, well, how do we measure effectiveness now? Like, how do we measure how well an engineer is performing? How well are we measuring the quality of a product? We see a lot of companies bragging that we've generated X million lines of code now just through AI. Mm-hmm. And that is impressive, not to take away from that. But is that the real thing to measure? And is that how Intuit?
We have a lot of metrics that we use here, PRs, CRs, numbers of reviews, lines of code, all those kind of traditional metrics, I think are still relevant and interesting. But ultimately, the metric that was and continues to be the most important one is whatever we did in the technology, did it generate customer value, and how do we measure that? And I think that the speed with which we can actually put things into the production environment, explore different variations of things. We do a lot of sort of experimentation inside of Intuit around, does this version of this experience work better than that version? We don't have to choose anymore. Can we do 2 experiments? Can we do 5 experiments? Can we do 9 experiments? Can we do 900 experiments? We actually have the optionality of experimentation has become much greater. And I think that's really very super exciting, right? Because now we're not just getting at like, okay, these are great ideas. How can we actually try them all out? How do we try them all out with velocity? How do we actually get the right metrics and instrumentation in place? It's much easier to do that now. And ultimately what we want to do is really deliver value for customers. And I think that's still the same metric, that existed 5 years ago, 10 years ago, today, tomorrow, 5 years from now, right? It will be, we will build all this technology to make someone's life, job, activity better, happier, easier, right? And make an improvement. And so I think it's the same thing. And it goes back to, I think, the core of this talk we're having, which is humans have always been at the center of software engineering, right? And so I think it really is even more so now super important that engineers are really empathetic and in tune with who their customers are and what's important to them, because they're so much more easily able to have impact on that customer experience than they ever have before.
I especially love that idea that we're here to create things that people want to use. I think when you say like it's still a human experience, I would say in how we consume it and how we generate it. That's still very much a human adventure. And I'm kind of reminded to really date myself back when people thought like, oh, who's really engineers anymore? Of like when IDEs came out and all these integration tools and all these other tools of like, what do I do as an engineer? And that continues to evolve. And I think this is another phase of that, of we have to figure out like what does an engineer do? What are those skill sets? Is it now more playing like coach in how you're getting your agents to work together? How much of that is hand and understanding the system? So when you mention kind of like the speed part is what's really exciting. What do you think is kind of the new bottleneck? Before is like how fast can we generate code was classic, not always, but classically one of the bottlenecks. What do you think is going to emerge as the new bottleneck?
We just had a big planning exercise with my organization, a couple of weeks ago. We actually started the planning, process saying, let's go build a Q4, a quarterly roadmap. And we said, let's not do that. Let's actually reimagine what it will take to deliver that roadmap. Because when I start to look at backlogs across my teams, what I started to realize was that we were thinking too small. And what we could look at and be like, yeah, we can do all of this and more. And so really you start to really change the conversation around, okay, where is design? Do we have enough designs? How are we going to work through design iterations more quickly? Where's product? Where are product requirements? Do we need really sophisticated product, PRD documents with all kinds of nuance and details documented out? Or do we need sort of sketches of what we want to try and then actually then kind of co-develop with a PM and an engineer a bunch of different scenarios for a particular feature? And so I think, where do we see the bottleneck? The bottleneck is really in the ideation process to get from, hey, here's a cool idea that solves a customer problem to here's something running in production. And, trying to figure out how to retool a lot of those working relationships, experiences, handoffs. What does it mean to be design complete in an era where it doesn't really matter? Like we can change the design tomorrow and build a new one. It's fine, right? And so I think that's more of where the bottleneck is the process of constructing the software, because, I remember when Scrum became the way that you did, software engineering, and you had product owners and Scrum masters. And, it was really transformational in terms of moving from this kind of waterfall approach to more of an agile iterative approach. And I think now we're in a new approach and we don't really know how to do it well. I would say we're sort of experimenting and learning through the process. But I think that's very much what I see the bottleneck is today, is the process itself is kind of slowing us down. And so I think teams are having to go back and retool. And depending on what they do, if they build a front end store experience, they can probably do a gajillion, they need to think about it one way. If you're talking about a back-end team that focuses primarily on sort of large-scale data pipelines and sort of mission-critical data ingestion, they're probably going to have to think about doing it another way. And so I think we're in this, again, really interesting time where we're reimagining what it takes to be a really successful software organization. We've gone from a tool to a completely different tool that's incredible, makes it so much easier to produce all of these types of application experiences.
That's great. I love the fact that the process is, I think, what's going to evolve. I'm extremely confident in 4 or 5 years, we're going to look back at how we're using these tools now and think like, how naive we were. The process is still forming. We're learning what the new normal is going to be. And I think a lot of organizations that try to push that boundary of like, let's rethink things. Let's step back from this kind of paved road and we're going to have to forge new paths. I would also love to explore the mindset of how like you tackle that. Cause I think you're talking about it in a very open-minded way of like trying to reassess these things. And does that just go back to experimentation, not so much just in code, but in processes? And how do you get other stakeholders and other departments in line with that?
I'll say at Intuit, we have a very collaborative culture, and teams really come together with their own points of view from their areas of expertise, design, product, data science, applied science, in software engineering, et cetera, and bring really work backwards to solve customer problems. I've had many, many people come into my office over the last couple of months, and we rolled out Claude Code to the entire organization. I had one of our designers come in and say, well, I set up Claude Code. Where do I check in the code now? And I said, okay, like what problem are we trying to solve? And they're like, I don't know. I just need to know where to put the code now that I have the Claude Code thing to do the, and so I think in many ways it's really, clarifying expectations around this is where we think some of these processes can be changed fundamentally. So we have PMs now producing PRs that go into our code base and get reviewed by an engineer and they go out as an experiment. That's great. Like we don't actually, there's no engineers doing any work there other than a PR review, and that's fine. We also have engineers still building wholesale features. What I would say is really, important to us is keeping that experimental learning mindset and understanding things are going to change, things are going to evolve. We don't have all the answers today, and whatever we think is great today, tomorrow may actually be completely different, and that's all okay. And so everybody kind of needs to be flexible in how they're thinking about things. I also think not necessarily challenging, but really being open to the idea that roles are blending. And so, PMs can now be engineers. Engineers can now be PMs. Like I've always been a big proponent of engineers and PMs kind of being just two sides of a coin, right? And you have very technical PMs and you have very product minded engineers, and, and you can sort of, in very small organizations, oftentimes they're the same person. And in bigger organizations, they kind of get more specialized but they still have a particular, that shared understanding. And I think that these tools are really opening up a lot of pathways and avenues for those types of experiences, which is great. I also think that, and I emphasize this with my teams, which is ultimately, this is no different to me than going from Emacs and VI to Eclipse and IntelliJ to now, to now a tool that's just even more robust in terms of the ability to kind of produce high quality structured, tech code. You still own it operationally. It still has to go through CI/CD deployment pipelines. It still has to be supportable and maintainable and instrumented. And we still have to have metrics and performance. And so, to your point of how do you get everyone bought into these things? It's not so much a buy-in as much as it's opening up the aperture around what it means to build, mission critical, high quality software across the board. Engineers are learning about product, designers are learning about code, product managers are learning about operational excellence and how all these things kind of come together. And it's been great. It's really helped people understand what are some of the constraints that exist in the teams and why things are hard to do sometimes, and really helped, I think, people have a much better, even more sense of shared empathy across disciplines and skill sets. And that's actually helped accelerate a lot of conversations, because now it's oh, now I get why that's super hard. Okay, let's do it this way. And they're totally, let's do it that way.
Yeah, I think empathy is a great word for it, of kind of pulling back the curtain of where some of those responsibilities and frustrations lie. And as you mentioned before, the ideation process kind of evolving, and people are now able to be technical that weren't so much before. I think especially in the ideation process, where I'm having really satisfying experiences is before, when we tried to translate business requirements or what we want to do. Mm-hmm. Now I can have PMs or designers say well, let me just whip something together real quick. And then they can actually show the interaction, show what they want that to look like very quickly, and people can touch it. Would I ship that code to production? Probably not. But is that a quick shortcut into getting us something that is there? Absolutely. And I mean, that's sort of an exciting time. And when you talked about running 9 experiments or 900, I think that it also goes to the number of things that we can tackle all at once. Mm-hmm. It's I challenge a lot of the leaders all the time when I talk to them about it. Do we need less engineers? Well, if you need less engineers now, the problem is you can't think of enough things to build or to work on. That's the challenge. How do I utilize all these engineers that are now superpowered? And I think trying to have that cross collaborative view of even having design or product tackle it, that's a really exciting way to keep all those things moving.
Yeah, I mean, Alex, our CTO here at Intuit, is I think he says it really well, where he says that he's been here a long time. He's never seen the backlogs go down. The backlogs of work that we are being asked to do by the business has never gotten shorter. And so he's the minute that we feel like we can do all this work with fewer people, that's a conversation worth having. But today we actually see the explosion of ideas. Right. And I think that, that it's this really exciting moment where, I think everyone now feels unshackled from constraints of gosh, it's really hard to get software to be built and delivered to. It's still hard, but the velocity and the ability to do more is so much better now. We're making more software now than we ever have. And I think that will continue to amplify and accelerate over time.
Love it. Yeah. So to speak more on a macro level of just kind of where the industry is, we try to, now that speed of development or even getting ideas out is not so much the bottleneck it was before. If you were talking to like the whole suite of engineers now of like, well, what do I work on? How do I differentiate? Like being really good at debugging or CI/CD or like this specific niche isn't as strong. What are the traits that I could really focus on to set me apart from other engineers?
I will tell all of my leaders and teams and team leads and people who are recruiting in particular, I think that there's generally two things that we evaluate for. There's sort of functional skills, and then there's how you do work. And I think that the how you do work part is unrelated to the functional skill part. And so do you dive deep into problems? Are you a strong owner when things don't go the right way? Are you customer obsessed in how you kind of think about the problems? And so there's a set of Intuit values that we have, speed as a habit. Can you unblock yourself and kind of figure out the way forward? That's orthogonal to, Claude CLI or, you know what I mean? Quoto or whatever. On the functional skill side, I think this is where I still do believe that software engineering is a skill set and it's a functional skill set. And so I think about it in three categories. You've got someone who understands algorithms, someone who understands how to solve a problem with technical mindset, and then someone who understands how to structure and modularize things and sort of break things down into smaller component parts. In the past, in years, you might do a coding problem in an interview with an SDE and you would evaluate, do they write logical and maintainable code? Right? Can they create classes and structures and interfaces? And do they understand methods and how that all kind of comes together, regardless of language? And I think today, it's like important you to understand that, but it's even more important that you understand how modularity can occur. Because if you're going to go generate a 12,000 line PR, it can't be 12,000 lines in one class, right? That's not okay, right? And so similarly, like we still need people who understand algorithms, like database queries, big data processing pipelines, like ETL. Like these are still problems that require algorithms. Like you still need to know what an O of N means and how you get to that across different types of implementations, right? And I think there's general problem solving kind of concepts, which is, hey, like, there's a million questions out there on the internet, right? If you buy stock here and you sell stock here, like what's the best time to buy and sell stock? You know what I mean? Like that sort of thinking mentality is still needs to be there. And so I still think that those are the three kind of functional areas that we still evaluate engineers on in terms of how to be a great engineer. And so should you know debugging? For sure. Should you know CI/CD? Absolutely. Like those are still concepts in software engineering, but at the foundational level, like you can't understand algorithms, like you're not going to be successful. No, there's no Claude CLI that's going to help you be successful with that, right? Like it's not, we're not there yet. Maybe. Right? Maybe at some point in time, but like today we're not there. And that's kind of where I do, I think it's very interesting because our most senior engineers, when I think about our staff, senior staff, principal engineers, these are folks that generally are seeing, I've had one of them in a one-on-one recently tell me they're 100 times more productive than they were before CLI. And I actually believe them. They're like, I can just like move through things so quickly because I know how it works. I know how to kind of construct all these things. Our more junior engineers, I think this is where I don't want to say worry, but this is where I think we just need more attention as an industry. Because I grew up at a time where software engineering as a discipline was learned by the people sitting next to you writing that had written more code than you, right? And you understand it's almost like being a cabinet maker or a plumber, or it's that kind of a craftsman type approach to learning.
Tactile experience, so to speak.
Exactly. And I think that's the thing we've got to figure out. How do we teach that over time? Because you need controls and guardrails and all these kind of things to make that work. And that's something we're thinking a lot about, which is how do we sort of make our best developers 100x more productive, which is great. And how do we make sure that the folks that are kind of new in career and or learning this are able to kind of catch up and like ramp into this experience in a way that is healthy and productive for their career development.
Especially around like the ownership of code and like needing to understand the algorithms. You need to understand how it works. I was actually at a university. I'm not going to say where yet, but I was getting to monitor some of their students that were making presentations on what they could do. And someone with the best intentions that we pointed out some like, oh, could you have done this different in the code? There seems to be some concerns there. And they said, well, that's just what Claude outputted. So like, and there was almost a dismissal of ownership around that. Like, that's a mindset we have to tackle. Like we have to think of these things as a tool. You still own what you build. You still have to be responsible for what goes out. But you also have how we kind of mentor these junior engineers coming up, speaking to other organizations around, well, now we only need senior engineers that can build this. And maybe that's true, but you know where senior engineers come from is junior engineers. Like you have to create them eventually.
Right.
So what is that way of how people get into the industry? I remember for myself, there was this aha moment of when I was able to make something move on the screen because I coded it and I was hooked into development. And that experience is somewhat dulled now, perhaps with some vibe coding things that people do and stuff like that. So
Yeah.
how do you think that you're going to get like the next level of engineers, one, get them in the industry, get them fruitful in learning, get that tactile experience you mentioned, and how do you kind of keep them mentored outside of like that normal motivation?
Yeah. I mean, I think from one standpoint, I feel like we've opened up the aperture of people who are now exposed to what software engineering can do. And so, I also had a similar experience when I was younger. I was, teenager, and I was in my basement, messing around with Visual C++. And it was like, wow, this is super cool. I didn't even know this was possible. Like, and that, led into my career, right? I think that now there's a lot of folks that are like, wow, I can just go in and make a website, or I can make a little tool, or I can do a thing that solves a problem. In many ways, it kind of brings me back to when I was younger, and it was like software wasn't quite the thing it is today. There were, a handful of programs, and you'd go to the store and you buy them, and you'd put a, floppy disk in a drive and you'd install it. Right. And nowadays, like the idea that someone could just make an app and use it, I think is really super empowering. Right. And I think that will actually bring a lot more people into wanting to be a software developer, wanting to be a software engineer. I think that's where we'll get back into, okay, well, you can be a great prompter, but you still have to understand how to modularize. You still have to understand, like, and it's not classes and interfaces. I mean, it is, but like, can you think about breaking down the problem into smaller component parts? Can you think about how these parts interrelate with each other? Can you think about the dependencies between them? Can you think about how, you might imagine, you use other kind of corollaries like, hey, messages are passed from here to there. What happens if the message doesn't come? How do you deal with like, an error? How do you deal with these kind of non-happy path things? And I think that will be where, those skills and disciplines will still need to be learned. And I think it could be that people could still learn how to program in Python or whatever, kind of an easier, I'm saying easier language. Not that the Python isn't, complex, but right. It's very different from like building your own data structures in C, right? Which is, a very different level of software development. But I do think it's going to open the aperture to who can be a software engineer. And I think it's going to really make an opportunity to bring training programs and, learning content into, for like Stack Overflow into, I'm a graphic designer. I want to build, software now. I want to make graphic software now. Cool. How do you think about, 3D object collision? They're going to have to think about, that's a thing. Do you know what I mean? That a designer probably doesn't have to really worry about, like, how does that mesh actually move? And how do you think about the physics of that? And so I think it's for the curious person who's really interested and has that kind of learning drive. They're going to be great. We're going to have this explosion of these great software engineers that come from new disciplines, new backgrounds, new areas, simply because they're like, this is really super cool. And now I understand it. And it's taken away demystified, like the languages themselves, which are kind of hokey anyways, honestly. Like none of them are amazing, but solving problems is amazing.
Yeah, solving problems is amazing is what should be on a t-shirt for engineers. I think that's like a great slogan. Um, but yeah, and I know what you mean about like kind of being welcoming and to all the Python fans out there, we love you, but it
I
is a
love
very
Python.
welcoming. I do too. It's an extremely welcoming language. It's what I really suggest for a lot of people that want to get into programming. Like it's very readable. It's still very powerful. You could last your whole career building great software with Python, but it does get over some of that intimidation hump, which I think AI is helping people do now. I think you're referencing like, I can do this with even less work. But the understanding of how it works is, I think, also real important. There was a staff engineer here at Stack that he has a prediction, and like all predictions, we're probably wrong. But he says he thinks in like 2 or 3 years, we're going to learn how we do things, but it's also going to expose some gaps in prompting or understanding in the software because how you prompt it, it is going to try to accomplish the task you put in front of it. It does not think about flexibility or like portability of your code in the same way a human being will. So in 2 or 3 years, when we want to build on top of these foundations and like, crap, we have to go back and rewrite it, or we have to do all these things. I think that's when that understanding is really going to shine through. And maybe that's how some junior engineers find and cut their teeth of like, all right, we have to go back and reassess some of these things.
Yeah, no, I very much agree. And I don't know that we're 2 years away from that. I think we're much closer to that becoming a bigger challenge than we think. We start to see this now. And we actually, when we think about agents, right, that we're sort of guiding, not just generating code, but actually empowering to take on specific parts of the engineering process. So we might have an agent that, there's a quality improvement defect that we're sort of working through. Here's a corpus of data, run the code, identify bugs, fix the bugs, run the code, you know what I mean? Kind of just have this self-improving loop essentially. And you can see those agents like go off into, crazy land and produce all kinds of things that you may not want, kind of that are technically part of the fitness function, but actually not actually helping you in the end. And so, we think about things like how do you create adversarial agents to monitor your agents and sort of check in on them and figure out, hey, are you still doing the right thing? And, almost think about agents as, and sort of when I think about some of our senior folks, I see them develop these agents and then they're sort of becoming like a software manager. They're like, hey, what's my agent doing today? What are you working on right now? Like, how are you doing on that? And sort of, and I think going back to some of your questions around how do we measure efficacy and effectiveness of some of these processes, I think we're going to see some of that naturally evolve out of sort of the idea that you can create these autonomous coding agents for specific tasks. How does the person who's managing that agent now demonstrate like, hey, what is it doing? Is it making progress? Is it screwed up? Did it do a good thing? And I think we'll learn and evolve. And it's very exciting. Like I said, it's an extremely interesting place because it feels like we're genuinely solving a bunch of problems today and encountering these high ambiguity situations versus just saying, here's a spec, here's an architecture, we're just going to bang it out. And, we know how to do this in a very predictable way, which was fine. But now we're in this mode of going, yeah, like, okay, I can make an agent to do this and an agent to do that and an agent to do this other thing. And now I'm just managing agents. And now how do I actually manage the manager? Right. And those kind of relationships, I think is going to surface up a lot of these gaps you're describing, which is, hey, the agent wasn't that good. It produced a bunch of garbage and now we got to start over. Do we just blow it away? I had one of my principals tell me, we're going to treat code like cattle, not children. Right. And it's like, be much less precious about it and essentially be like, you know what, we can just start from scratch whenever we want. And that may not be a great idea. I was like, cool your jets there, my friend. Right. Right. But it's probably an interesting thought experiment, right? Which is again, when the incremental value of that line of code is like 0 or approaching 0, why not just rebuild everything every day? Maybe. I don't know.
That is an interesting thought, and there's a lot to unpack in that cattle versus kids analogy. Well, but no, like as it does approach 0, does rewriting it all make sense? And how much are those agents cutting their teeth on facing real world feedback of like any software? And I don't think this is going to change even with agents. Like any software that meets the customer for the first time, it's going to find problems. It's going to have to evolve, and the way that you do that's important. Is if we start over with a rewrite for every iteration, are we losing some of that sharpening of the code? And maybe we don't. Maybe we do. We're figuring it out.
I don't know. We're figuring it out, right? And I think it's like I said, it's a very, we don't know how these things are going to play out over time, right? It's only been like my sense is that the tooling got really good 4 or 5-ish months ago, right? Before that, it was fine. Now it's really good. What's going to happen now? I don't know. Is this it? Is it going to expand from here? Maybe. Like, is it going to stay flat? Maybe. Like, is it going to become incrementally so complex that we're not going to even understand it anymore? Maybe. I think that's the judgment part, right? That was the sort of prompt for this conversation was like, where do humans fit in? Right there. Like, that's where people are needed a lot.
So, I think we've been talking a lot about how we can enable our engineers as leaders to, use these tools and move faster, which is of course a huge part of it. But there's kind of maybe the less talk about part is as engineering leaders, what do we do to utilize AI to help in our day to day and kind of help make these decisions? Is there anything that you try to follow or anything that really jumps out to you that this is what's leveled me up at my level to go faster?
I would say there's very little of my day-to-day at work activity today that is task oriented that I don't use AI for. So for just some examples of, right? I built an agent that reads my email every day, summarizes it, and basically suggests responses to things. And then I can go in and sort of, tune it and sort of, craft it in my tone and messaging. And it kind of develops that over time. And it saves me from having to filter through, create super complicated filters in my email. And it sort of, make sure I'm attending to the right things. Do the same thing with Slack. I'm sure like you and everyone else, you get 4 million Slacks a day. It's just really helpful to sort of understand, okay, how can I self-identify like who should be in my VIP category? How do I respond to these folks? What are the summaries? And so those kind of tools are great. Also use AI around, frankly, a lot of synthesis of documentation. And so, I like to read specs. I actually will go in and sort of, use AI to understand, here's a PRD, here's a tech spec, here's the code. Did we actually produce what we wanted to produce? Right. And sort of use that as an interesting framing or an interesting investigation into like, are we getting the right outcomes from the tech? We use it a ton around diagnostics. So we actually use it in terms of here's a bunch of log data. What can we go in and actually look at and find anomalies? How can we actually use that to then drive improvements in the product? Some of those agent type experiences around a lot of the task based parts of the job, I think can be somewhat outsourced to agents. Now, it still requires a human in the loop. Like in my email thing, I'll be honest, like I started out having it send email for me, quickly stopped doing that. That was a bad idea. What was a good idea was like, hey, just read it all, summarize it, and give me give me the sort of cliff notes of it, and then let me kind of go back in and like really look at like the detailed parts of it to just separate kind of wheat from so what was important and what was less important. Any kind of planning, any kind of synthesis, any sort of I'll actually have like whole projects in both in Anthropic and in OpenAI where I can actually create projects around things like, for example, employee promotion documents. And so I'll actually have a project for, such and such employees promotion. I'll put all their code in there. I'll put all the documentation they've written in there. I'll put I can have it help me summarize from that and then use that as an input to actually go. And when I actually write the promo doc, use that as a way to make sure that like I'm kind of co-working with it. I can also use it to actually do research. So this is a common, thing. I'll go in and I'll say, hey, I'm looking at this particular, competitive product, customer use case, whatever, like actually like chat with me about it and help me understand like how this relates to other products, other technologies, other offerings, other types of things. And so I just think it's super important tool for everyone, not just for code generation. I think it has to have a human in the loop at every step in those areas. But I do think it's a significantly better way of sort of aggregating unstructured data and trying to make more sense of it in a way that you can do with kind of a natural language interface.
Eric, thank you so much for joining. This has been fantastic. I think you got a lot of cool insights on how we can use AI at engineering and even outside that level. And really excited to hear how things go at Intuit and what's going to come next.
Thank you so much, Ben. I am a huge fan of the work you do over at Stack Overflow. Thank you so much. And I look forward to seeing what happens next.
Okay, that's going to do it for this episode. Today we spoke with Stack Engineering Director Ben Matthews and Intuit Engineering Director Eric Anderson. My name is Ira May, and I'm the B2B editor at Stack Overflow. If you have any suggestions for topics you'd like us to cover or guests you'd like to hear from, you can email podcast@stackoverflow.com. Thanks for listening, and we will see you on the next episode of Leaders of Code.